Hi, Period 8, it's Mrs. Guest. Sorry I can't be with you today. I have a professional development meeting, unfortunately, this last week of the school year, but we need to keep it moving. So here is, some highlights, I guess, of the ratio and proportion concept that I want to make sure you're comfortable with. As background, we are going to have a quiz on this topic tomorrow. You will have an opportunity for additional practice here in class today. You will be given an answer key so you can review how you're doing, and you can identify any questions you would like to ask me tomorrow before the quiz. Please make sure that you're trying the problems independently. You're welcome to talk with others about strategies, but use it as practice to study for the quiz. You'll also be getting an extra credit opportunity today. That will be due by Friday if you want to take advantage of that extra credit, and will be worth 10 points additional in the homework category. All right, so ratios and proportions. First of all, ratio, a comparative of a number A and a non-zero number B using division. So that might look like this: A to B, A colon B, or A over B. And of course, the reason B has to be non-zero is because we can't divide by 0. Okay. All right, a proportion, an equation that states two ratios are equal. Maybe something like A to B is equal to C to D, where those are all numbers. For example, 2 to 3 is equal to 4 to 6. They can both be simplified to the same ratio. Okay. They talk to you about, in a proportion, that the numbers B and C are the means of the proportion. A and D are the extremes. One of the tools I use to remember that is if I kind of read this left to right, top to bottom, it would be A, B, C, D, right? A and D are the first and last. They're at the extreme ends of that list. B and C are in the middle. Sometimes we think of a mean as being, middle-ish, not necessarily the median, but, a middle-like characteristic of a data set. So if you need that information to try to differentiate between the means and the extremes, some sort of tool like that might be helpful to remember. And then the cross-product property, which we'll look at in a moment. Okay, so first task you had was simplifying the ratio. They gave you two ratios here. The first one, 6 days to 15 days. They wrote as a fraction. When we're simplifying, ideally we are getting rid of units. So days over days is like 10 over 10, right? It reduces, it simplifies to 1. And then we have 6 and 15, both divisible by 3. The end result, the simplified ratio there, 2/5. 2/5, 2 to 5, or 2 colon 5. Okay, different ways that we could express that ratio. The second one's a little different, however, though, because the units are different. So we can't just cancel them out. We need to do a little conversion. It's easier here to convert the yards into feet. Each yard is 3 feet. We've got 2 of them, so 2 times 3. We end up with 6 feet. So 2 feet over 6 feet. Now the units can cancel out. I'm then left simplifying 2 over 6, which of course those are divisible by 2 to get to 1/3, or 1 to 3, or 1 colon 3. Okay, so that's the task you were asked to practice on your own at the bottom. So 6 inches to 28 inches. I could write as a fraction if I prefer. Both of those are divisible by 2. The units are the same, so let's cancel out. 6 divided by 2 is 3. 28 divided by 2 is 14 rather. So I end up with 3 to 14, 3 to 14, 3 to 14, depending on which way you prefer to write your ratio. In the next one, I notice as well the units are the same, so they cancel. Here, I can divide both numerator and denominator by 6 to simplify, and I get 3 to 1. You could simplify that as just 3, or you could describe it in either of the other forms. Okay. This last one, the first thing I notice is the units are different. I have a choice. I could convert them both to feet, or I could convert them both to inches. That's really my choice. Here, I'm going to choose to convert them both into inches. If this happened to have been a multiple of 12, maybe I could have considered converting it to feet, but it's not. So I am going to convert to inches. So I get 27 inches to 36 inches. My units cancel out. I can divide both numerator and denominator by 9, and my result would be 3 to 4, okay, in any of the forms that we've discussed. I did have a student in another class say, well, how can that be? Because 27 is bigger than 3. But again, it's 27 inches and 3 feet. 3 feet is bigger than 27 inches because 3 feet is equivalent to 36 inches. Okay? All right, moving on to the back. On the back side, now we're going to play around with the ratios a little bit and reconnect with the segment addition postulate concept. So the segment addition postulate concept says if I've got a segment here with a between point, a point that's in between and on the same line or line segment, this segment plus this one would be equal to the entire larger segment. So we've got some information. The ratio of xy to yz is 1 to 5. And just like our last topic, order matters. So segment xy is associated with the 1. Segment yz is associated with the 5. Okay? But obviously, the length here is not 1 and 5, because that doesn't sum to 24. So they've chosen to take an approach of using a variable to represent a scale factor. How much are we having to scale the 1 and 5 by in order to get segment lengths that sum to 24? So you see here, right, that they are using the length of segment xy plus the length of segment yz equals the length of segment xz. We've defined segment xy as x, or 1x, same thing. Right? 1x plus 5x equals 24. We combine our like terms. We divide both sides by 6. And we conclude the scale factor that we're using here is 4. Okay? X is equal to 4, which I can then substitute back in to say, well, 1 times 4, that's just 4. So segment xy has a length of 4. 5 times 4 is 20. I can check that. 4 plus 20 is indeed equal to 24, okay, which is what I expected. And the ratio of 4 to 20 is equivalent to 1 to 5, which is what we started with. Okay, so those are ways I can check. So they asked me to find the length of xy, 4, and the length of yz, 20. I've completed that task using an understanding of ratios. Okay. All right, so let's look at the examples here, and we will talk about a couple of other approaches people sometimes like to take. In this example here, we're talking about the ratio of segment AB, its length to the length of segment BC is 2 to 1. Okay. Obviously, it's not 2 and 1. That's only 3. But I can use a factor. 2x plus 1x has to equal 15. 3x equals 15. And, of course, 3 times 5 is equal to 15. So my scale factor is 5. I'm able to substitute that. 2 times 5 is 10. That's my length of segment AB. 1 times 5 is 5. I can check it. 10 plus 5 equals 15. And the ratio of 10 to 5 is indeed 2 to 1. Okay. This next one will model a little different strategy. Again, we've got the ratio of DE to EF, 4 to 9. Some people like to think about it this way. 4 plus 9 is only 13. Okay? Not 39. 13 times some factor would equal 39. And of course that factor would be 3. 13 times 3 equals 49. So if I use that here, 4 times 3, well, that's 12. 9 times 3, 27. Okay. And I can check. 12 and 27 are equal to 39. And the ratio of 12 to 27 would be 4 to 9, which is what I started with. So that's a way I can backward check. And then finally, this one here, I would guide you to be careful. The relationship is not always the left-hand segment to the right-hand segment. So remember the order matters, and check and make sure you're labeling appropriately. 6x, 7x, I'm going to use x as my scale factor. 6x plus 7x must be equal to 26. 13x equals 26. X would have to be 2. When I substitute 2 in for x, I have 12 to 14. Those guys sum to 26. And the ratio of 12 to 14 would simplify to 6 to 7. So I have met the objective. All right, and then the last task. The last task here, we're using the cross product property to solve a proportion, to find a value of x that would make these two equivalent ratios, right? The definition of a proportion. So there is a common error that people may make in this situation, but before we get to that, let me just mention that A to B equals C to D. Using the cross product property says that A times D would be equal to B times C. And that's something you've learned some time ago. But I do want to reinforce that's not just a party trick. It is rooted in algebra. If I were to try to get rid of my denominator here, I could multiply by b. b over b is 1. But I'd have to do the same thing over here. Right? You can think of that as b over 1. So I'm left with a equals c times b, or d times 1. If I want to get rid of the d, I could do the same thing here and would have to do it to both sides. And I'm left with d times a equals c times b. I can use properties of multiplication. D times a is the same thing as a times d. C times b is the same thing as b times c. So AD is equal to BC, which is what we had up here. Okay. Using the cross product property is just a shortcut, but it's rooted in the algebra, so no party tricks. So if I use that for their example, the thing I have to be careful here is it's 3 times the entire quantity x minus 1. 3 times x minus 1. This is where people, if they're going to make a mistake, tend to by forgetting to distribute. So 3x minus 3 equals 2 times 9. And then it's just the algebra to conclude x equals 7. Okay. If I model that down here, 14 times x equals 2 times 7. 14x equals 14. X will, of course, equal 1. Here, 5 times 21 equals 7 times the entire quantity, y plus 1. 105. 7y plus 7. I can subtract 7 from both sides. 7y would be equal to 98. And when I divide both sides by 7, I would get y equals 14. There is another strategy, though, some of you may be using. And that would be to look at, again, the scale factor, which should say to get from 7 to 21, I'm multiplying by 3. Right? So if I multiply 7 by 3 to get to 21, I would have to multiply 5 by 3 to get to y plus 1. So another way to think of this is that 15 equals y plus 1. And of course, y would have to be 14 for that to be true. Okay. You can also look at a scale factor as being a fraction or division, right? Here, 27 divided by 9 equals 3. So x minus 5 divided by 9 would have to be 2. If I want to get rid of that 9 in the denominator, I'd multiply both sides by 9. So x minus 5 would have to equal 18. Adding 5 to both sides, I would be able to conclude that x must be 23. If you have questions about any of these problems or the practice you will have with the answer key, please make a note. You will have an opportunity to ask those questions at the start of class tomorrow before we have a quiz, and then we will be moving on to the similar figures topic where we will be using ratios and proportions to complete those tasks. All right, have a great rest of your day.